right, we are back, and we are going to look at some problems dealing with percentages, and we'll try to sift through them, see different ways to look at these sort of problems and how these sort of tools can be used properly and improperly. So I'm not going to read through every question, but I'm going to highlight some points and talk through how we would go about solving them. So for number one, we're looking at a staffing firm, which is was a legitimate statistic, I believe I pulled from either Jordan Ellenberg's book or somewhere else, but 52% of surveyed employers said they were having trouble filling job openings in 2014, which was a big jump from only 14% of employers were having that problem in 2013. All right, so we want to describe this jump in two different ways. Well, one way is by simply looking at percentage points. All right, 52% is a ratio, so is 14%. We can look at the difference of ratios, and that is simply computed by doing 52 minus 48. So it went up 38 percentage points in terms of employers indicating this issue. Right? Well, another way we can look at it is we can look at percent change. In 1 year, we're measuring the same sort of thing from 1 year to the next. So we can talk about the percent change between years. So we might do the new value minus the old value all over the old, I don't like that, but all over the old value. Right? This will give us a decimal, which if we multiply by 100, right, will be exactly, right, our percent change. So notice that 38 relative to 14, the difference 38 relative to what the old percentage was, the old value was, is quite a bit. Quite a big chunk of it. In other words, it's 271% of it. It's more than double. Okay, so if we wanted to make this change seem very drastic, all right, we would probably look at percent change, because we would say, well, this need went up by, or this statistic went up by 271% over the course of 1 year. That's a large change. Right. So a good question, a good mathematical question, real world question is, what situations or who might you think would choose to use, let's say, this second statistic over the first statistic? What would what could their purpose be for using that statistic? Right. Let's look quickly at number two. Right. So according to Metro Social Services in Nashville, the youth poverty rate, right, in Nashville went from 18.9% in 2012. That 18.9% of youth under 18 were living in poverty in 2012 to 17.8% in 2013. All right. So we want to describe this change in two different ways. All right. Well, one that makes it look large and one that makes it look small. So I went through and I looked at percentage points. All right, the difference between these two ratios. All right, that difference is simply, right, I take 17.8 and I subtract 18.9, so that means that we went down 1.1 percentage points. A good sign, because it's going in the right direction, but not much of a change. Right. Now, if we look at percent change, all right, again, we've got a new value and an old value. Okay, so we can take our new value, 17.8, that's a 9, but 8, and subtract off our old value, and then we would divide it by, right, our, which value? The old one. It's the old value. 18.9. It's very looking good centered, right? And so we should get, right, some sort of decimal, which if we multiply by 100%, right, would give us the actual percent change, right? And so I think, if I recall correctly, this was a 5.8% change, percent decrease, all right, which seems like a larger number. All right. It tells a somewhat different story than the negative 1.1 percentage points, depending on what we want to get across. So one thing I would encourage you to do, if you're unaware, is figure out, do you know what the poverty line is? What the poverty line is in terms of for a family of four or for one individual, all right? Because they're different, right? For a family of four, I believe it is only the poverty line is 22,000, either 4 or 900. I'm working off the top of my head, just came to me, but think about what that means in terms of the youth in Nashville, right? And I would encourage you to do some research and look into poverty rates across the United States, and also look at what the poverty line is, right? And compare those to different countries and that sort of thing. It's an eye-opening experience about looking at poverty simply within our community, even. Let's take a second, and I'm going to just briefly talk about number 3. All right, and I want to highlight different ways to solve this problem. So number 3, we've got lobstermen netted a record catch of over 75 million pounds of lobsters in 2006, and we have that was a certain percent increase over the previous record catch in 2004. And so we want to then say, all right, if we know it increased so much over these years, what was the original weight? Right? So one way we can look at this is we have a new value. Right? We have a new value of 75,298,328, I believe. Let's add some commas to make that a little clearer. All right. And then our old value is something that we don't know. It's an unknown. All right. So the first way to solve these is to use our formula, right, and sort of backtrack, try to figure things out, do a little algebra. So our new value, 328, minus our old value, divided, all of that divided by, we'll use that for divided by this time, our old value, right? That should give us what? Take a second and pause and figure out what that should give us. 2, 1, we're going back to it. So that should give us our percentage as a decimal, right? In other words, if we take that decimal and multiply by 100, we should get exactly the percent change. Okay? So here we could solve for x. The best way to do this from this point would be to multiply both sides by x. Right? If you do that, you'll get something like 75298,328x minus x squared. The squared is equal to 0.052x. Right? And then you can go about things there. Oh, actually, let's take a second and pause. What did I do wrong? Here, you wouldn't have this. You'd have just that, right? I was going to write it all out, but so the x would, you multiply both sides by an x. The x multiplied in here would cancel with this denominator. You'd get an x here, and you go forward and solve from there, right? So that's one way to go about it, all right? And if you continue down this way, notice that you'll get 75298,328 is equal to 1.052x. Okay, what is this saying? Right? This is saying that this 75 million number, all right, in other words, our 2006 total is equal to 1.052 times our old total. Well, that's exactly, all right, saying that. All right, our second way of solving it is starting down here and saying that, all right, we have our old total, and that is actually equal to x, our old value, plus our new value, plus 5% added on. Right? So that is our old value plus 5.2% of it will get us our new value. Right? That's exactly what we're trying to solve. So you could either start down here, right, or start up here, right? Either way, you should be able to solve for what x is, right? Either way, you should be able to piece this together. So be careful, go back, track through that. I misspoke once, and make sure you know that this is our new value and this is our old value, okay? So we're looking at 5.2% increase of our old value, or 1.052 times our old value, should give us our new value. All right. So we're going to continue on. I'm not going to restart, even though I made an excuse or an error. All right, we're going to continue on, and we're going to look at what we call a Fermi problem. Fermi problems are problems that, are kind of large estimation problems, problems that are difficult to really figure out, that are often given to see, really test someone's problem-solving ability, or ability to come up with reasonable estimations, and that sort of thing. So there are around 200 faculty members at Belmont, and let's say we'll estimate the mean and median wealth among Belmont professors and how those numbers would change if Mark Zuckerberg joined Belmont as a CS professor. Well, I'm not really concerned about you figuring out the mean and median in terms of Belmont professors. Let's say we'll talk about wealth for a second, and we're going to focus on median. All right. Hopefully you remember that median is if we list all of our numbers, lowest, our values, lowest to highest, the median is that middle number. All right, so if I list the number 12, 14, the numbers 14, 16, 20, and 21, all right, they are in order from lowest to highest. 16 is our median right here, right? Well, if there's one more number, all right, in other words, if there are even number of values, all right, then what we do is there's no singular middle number. So we take the two in the middle and we average them. So this averaged between 16 and the average of 16 and 20 would be 18. Right? So if we're looking at median, all right, adding Mark Zuckerberg's wealth to our total wouldn't change things all that much, right? In other words, we'd have every Belmont professor's 200 numbers listed out in terms of their wealth, and then you'd have this huge Mark Zuckerberg number at the end. Well, all it would do is it would change. So, for example, I'll do it here with this. If we added $50 billion or something like that, right, the median doesn't change much. It would be 20 now as opposed to 18 before, right? So that's kind of just reminding you what median means. What about the mean here, this measure of center? Okay? How would that change? So what we're going to use here is actually weighted means to figure this out. So let's say that the average wealth of a professor currently is about, let's say is about $75,000. I'm not going to comment on anything. Let's just say that's what it is. All right. Then what we want to do is we want to be able to figure out, adding in Mark Zuckerberg's wealth, all right, how does that change, right? In other words, how does that change from where we were before? So let's say we now have we've got 200 data points up here, all right, 200 data points at $75,000. Okay, there we go. Sorry, I was trying to grab this. Okay, so in other words, there are 200 faculty whose average, all right, is about 75,000. Okay, now obviously there's fluctuation in there. So what we have is really a before average and an after average, a before Mark Zuckerberg and an after Zuckerberg, BZ and AZ. Okay, so there are 200 faculty, and their average is 750,000. Right, in terms of wealth. And now let's say we add in Zuckerberg, okay, and his wealth is something approximately, let's say 50, I think it's about 50 billion, all right, give him plus or minus, let's say. All right, so now instead of 200 data points, we have 201, okay. Well, we knew the first 200 averaged out to 75,000. Okay, and this last data point is 50 billion. Okay, so the question is, what is our new mean? How much does that data, that outlier, skew our number? All right, north. In other words, increase it. Okay, so the way we do that is we use the weighted mean. We say we have 200 data points at 75,000. Right, so 200, right? Or if our value is 75, we've got a weight of 200 people there, right? And then we also have, right, a weight of 1 at 50 billion, right, in terms of salary. So now we've got these, our values. So this would be like X1, and this would be X2, and this is W1, weight 1 right here, and weight 2 right here. So we've got those things, and we need to divide them by what? Well, how many weights do we have? How many actual, right, faculty members do we have? Well, it would appear we have 201, right? So whereas before, with the 200 faculty, we had an average wealth of $75,000, let's say, adding in just that one singular, all right, outlier of $50 billion skews the data wildly, let's say. If you compute this weighted mean, you should get, I think you get something about 248,830,000. Let's just round it there. I think there's some more data there, but so that means now if we bring on Zuckerberg and we talk about the mean wealth of Belmont faculty, that means that quote unquote average, right, faculty member has a wealth of $248 million. That is not a reasonable representation of reality. Not reasonable representation of reality. And that's what we want. All right? We want to find reasonable representations of reality. Okay? So just to drive this point home, all right, and then we're going to talk about how this shows up with gentrification briefly. But to drive this point home, all right, let's say Zuckerberg joined a group whose wealth was zero. Let's say there was just Zuckerberg, right? 1 point Zuckerberg in terms of his $50 billion wealth. And instead of 200 people, let's say there were 999 people who had zero, right, dollars to their name. A wealth of zero. Okay. And so now our new weight would be the 1,000 people we have. Okay. Well, what's that mean wealth? That new mean wealth, all right, is what? Well, you've got 50 billion and you're dividing by 1,000, right? So you cancel out 3 zeros. So I believe you would have 50, not in Europe, million. So the mean wealth is $50 million per person, right? That is our average wealth. Again, that's not a reasonable representation of reality. Reasonable or meaningful. Let's just say or meaningful. All right. So, in fact, it's mostly not meaningful. So I do want to briefly tell you about, this is one of the problems with, or this idea, this weighted means, and how larger numbers can skew means of sets up, really is a real world problem because gentrification, for example, is something that's happening in Nashville right now and has been happening for years. And let's say that we used to have a city block, all right, where 20 houses averaged out at about $100,000 in worth. Okay, well, property taxes are based on averaging wealth of houses, more or less, and averaging the value of homes in that area. All right, comparable homes. So they would have an average of about $100,000 in value. All right, we're in a certain tax bracket in terms of property taxes. Well, now over the course of a few years, let's just say 5 or 10 years, all right, five of those homes are bought up, all right, and they are tore down and replaced with much bigger homes. So we've got 15 homes still at about $100,000 in value, and now we've got 5 homes that are, let's say, at about $500,000 in value. Okay. Well, what's the new weighted mean? What's the new mean? All right, and we'll use weighted means to compute it in terms of average value of the home. Up here, before, right, these 5 houses were redone and moved in, the average value, which would be used to compute property taxes, was $100,000. Down here now, though, right, in order to figure this out, hopefully take a minute, pause the video, and figure out the weighted mean here. All right. In other words, this value has a weight of 15 homes. This value has a weight of 5 homes. Take a second, pause it, figure it out. 3, 2, 1. You should get 200,000. So now, for tax purposes, the average value of homes here has gone up from 100,000 to 200,000, and we've only really taken 1/4 of the neighborhood and changed it over. So now, let's say someone was living at this level for years, 10, 15, 20 years, maybe their whole life, and we're paying property taxes at a certain level. Their property tax, depending on where they live and the property tax rules there, their property taxes might have jumped significantly here. Let's say this number goes up from 5 to now 10 of the houses have been changed over. All right? All right. Figure out our new mean. All right. What's our new mean? Well, you've got 10 at 100,000, you've got 10 at 500,000. I'm guessing if you average 1 and 5, you're going to get, typically when you do that sort of thing, you get 300,000. So now someone who's been living there in one of the lower valued homes, all right, is now going to be in a community where they're paying property taxes as though they live in a $300,000 home. And this is one of the key things at play when we talk about gentrification, and how unfortunately it's a very it tends to drive out people who have been in neighborhoods for a longer time who can no longer pay property taxes. It's one aspect of that, right? And so one aspect that oftentimes gets overlooked in the shadow of, ooh, there are fancy new homes, right? So I'm going to take a second. I'm going to take a break. We're going to pause it there. I'm going to come back and look at a few new problems in another video, and then we'll move on from there. So this will be part 1.